Earlier, I had used the term PERT, which stands for Program Evaluation and Review Technique. This calculation is not used often, but it will probably be on the exam. The calculation is the total of P for pessimistic plus 4M, most likely, plus O, optimistic, the sum total divided by 6. Again, the P stands for the pessimistic estimate, the M stands for the most likely estimate, and the O stands for the most optimistic estimate. So taking an example, our pessimistic estimate for a project or an activity is 21. The M is 16 and the O is 14. This calculation is done in weeks. So this would be 21 weeks plus 64 weeks plus 14, all divided by 6, which equals 16.5 weeks. The next formula you need to memorize is the standard deviation and task variance formulas. This one is calculated to find the standard deviation, which determines the confidence level of your estimates. The calculation is pessimistic estimate minus the optimistic estimate divided by 6. So in our previous example, the standard deviation would be 21 minus 14 divided by 6, which equals 1.67 weeks. To calculate the variance of a task using PERT is the sum total of pessimistic minus optimistic divided by 6 taken to its square. So the variance for our previous example is 21 minus 14, or 7 divided by 6, and taking that 1.67 result to its square, which equals 1.362 weeks. You might be asking at this point, what is this used for? And it's a good question, and if the following explanation doesn't answer this for you, work the examples provided at the end of this topic. It will help a lot. To find the duration and standard deviation for a project, you would add the PERT estimates for each activity on the critical path. The key is to remember that the calculation relates to activities. Do not add standard deviations, however. You would need to calculate the variances for the critical path activities, add them together, and then take the square root of that total. You would then have the standard deviation for the project. Another technique for schedule development is schedule compression. This is a form of mathematical analysis used to shorten the project schedule without changing scope. Another way of saying this is that it shortens the project schedule to accomplish all the activities sooner than estimated. It's performed when the project end date has been predetermined or when the project is going to take longer than the original promised date. And there's two techniques. The first one is called crashing, and the second one is called fast tracking. Crashing the schedule is a compression technique that looks at cost and schedule trade-offs. Several options here are either to add resources to critical path tasks or to limit or reduce scope. If you're looking to limit or reduce the scope, you'd probably review those features that are either necessary versus the nice-to-haves. Fast tracking is performing two tasks in parallel that were previously scheduled to start sequentially. It's important to note that this increases project risk and may cause rework, especially if you had a good reason for sequentially performing these tasks to begin with. The last technique we'll cover in this section is the what-if scenario analysis. This analysis uses different sets of activity assumptions to produce multiple project durations. It's a simulation technique that can be run many times, changing the duration of tasks to show the probability of all the possible project completion dates. One of the ways to calculate these changes is through a Monte Carlo analysis. Remember, this method of estimating uses a computer to simulate the outcome of a project, making use of the 3-point estimates for each activity. And remember, the 3-point estimates are pessimistic, most likely, and optimistic. The simulation will give you probabilities on project completion, project costs, and the overall project risk. This concludes our review of the tools and techniques for schedule development to this point. We have more tools and techniques to cover in the next section.